Hi folks, let's head back to DeBolt Machine with Paul DeBolt to talk about and look at lathe feeds and speeds and how we can use different inserts in turning different steels, compare the chips, compare the horsepower. Let's learn some more about lathe tooling. Welcome to another Wednesday Widget. Hi folks, welcome back. We are at DeBolt Machine. A few months back, Paul was kind enough to have us over to his shop and we cut 3 different types of aluminum, 2024, 6061, and 7075 to compare speeds and feeds and chips and kind of reading and understanding how to set up a lathe and how to get a feeds and speeds recipe. Paul said, you want to do the same video on steel? And I said, absolutely. Big shout out to Alro. When Paul proposed that we film this video, I reached out to my Alro rep and asked if they'd be interested in providing some drops or remnant pieces to help us get this video made, and they did. We really appreciate that. So we've got a range of cast iron, steel, and stainless steel. Same thing?
Yep. Got a variety of tools here to try on so we can see what it looks like and help you know what to look for when you start cutting, so you know if you're getting the best performance out of what you've got.
So it's the idea of not going too far to the extreme of rubbing or overpowering your machine.
That's right, that's right.
What insert style are we going to use?
Well, we got D and MGs here. Most of them are negatives. I have a few positives. And anybody that has a machine that's not got a lot of horsepower needs to use positive inserts.
How do you describe, is there a way to describe positive versus negative rake tooling? Verbally?
Well, yeah, the negative rakers are all going to be square on the sides. There's no angle on the sides of the insert.
Okay.
It's just straight on the sides, and the insert is actually tilted in the holder.
Tilted down.
Right. to get the angle. The positives are going to be flat and then have a steep angle on the sides or a relatively steep angle on the sides for clearance. So and they can't be turned over.
Right, you don't get the downside is you don't get the opposite side. So for production, it's higher cost per edge of the insert, but it's lower cutting pressure, so you get more horsepower out of the insert.
Yeah, well, or you need less horsepower to make it achieve the maximum effect.
Yep.
Okay, and you know, positive inserts have their plus side. Most of the boring inserts are positive because of the cutting pressure pushing down on the boring bar.
Yep.
To cut back on that, which helps you generate nice chips. At the same time, you don't have to use much horsepower, but it's easier on the boring bars unless you want to spend a lot of money on solid carbide. Yeah.
And I remember you were showing, Paul makes a lot of really cool model engine parts, and you had a really thin, I believe it was a steel part that was quite long, and you switched over to a positive insert trying to be able to cut that on your CNC lathe without getting deflection. Yeah. Pushing, the negative insert was pushing the part away, right?
That's right, that's right. The thin parts, that's the other thing. What kind of configuration of part are you making? If you're making something very thin, positive inserts, whether you're turning the outside or the inside, a lot less cutting pressure. That enables you to cut those things, where a negative, it's forcing on it hard, and it takes a lot of horsepower to do that.
Right.
So that's the advantages of positive inserts. A lot of people use positive inserts in aluminum for chip formation purposes, and negatives don't lend themselves to that, but you can buy ones with different chip breakers in them that'll allow you to cut like crazy, which some of you may have observed on the aluminum we did last time you were here.
But like the shear hog that we talk about so much, that's a sort of a custom geometry, but it's a really positive, just like the SHET inserts in a Superfly. In aluminum, they last forever. I mean, we could literally have hours upon hours of time in the cut with an aluminum positive insert. So you get the better surface finish, you get better bang for your buck in terms of horsepower. So steel, again, you gotta have a little bit more horsepower, a little bit more rigidity, a more rigid workpiece. Definitely what you see in production, right?
Yeah, and you can, negative inserts, if you got a negative lead angle, that affects your cut too, and horsepower, because you can thin the chip down. I mean, if you take a triangle and you're cutting on the side here, and you come to depth is measured from the end point of the tool down. Yeah. Okay, the distance from here across is longer than it is from here on the right triangle.
Sure, it's a hypotenuse.
Yes, and then when you cut using this angle going this way, it thins the chip and requires less horsepower.
Interesting.
So you can increase the feed rate
Basically, you're talking about really how you orient your tool post or the holder.
Well, you wouldn't want to do it that way. What you'd want is an insert that's, take like a triangular insert like this.
T. Okay.
And you have it centered in here, so it's actually cutting on an angle this side.
Not like that. That's kind of cutting more straight.
This is cutting straight,
Okay.
but you can get a holder to hold this insert like that.
Right.
Well, then it thins the chip, and you can increase the feed. Not only that, when it starts into the cut, you have an angle like this, and this is the edge of the part. It's easier on the insert because it's not so much shock when it starts cutting.
Folks, this is what we talked about. Card here to our sort of intro to speeds and feeds video. But when you make a good chip, you want to make a chip thick to thin. And when you think about it and you understand it, it just clicks. A thick chip means I'm coming in and I'm able to actually bite in. Just like with a backhoe, you take that backhoe bucket and you scoop into the dirt. The carbide tooling wants to make a cut. And then as you come through that cut, remember, whether it's a lathe where the part's rotating or whether it's a mill where the tool's rotating, you're rotating that cutting tool or the part. And when you exit that cut, you want it to go thick to thin, because when you exit, you want it to not rip a large chunk off. And I think there's actually some more physics to it, but that was my takeaway.
Well, and if you notice, a lot of milling cutters are 45-degree lead because they've got so much interrupted cut. Makes the cutter stronger and they don't have to withstand so much as a square edge cutter does.
It's funny you mentioned that, because you were pointing out this packet inserts, but you were talking about how on a lathe, so obviously any milling cutter, can't think of other than like a boring head, any milling cutter is interrupted cut.
That's right.
Because it's breaking the chips, it's coming around, whereas most lathe cutting is non-interrupted. Unless it's a feature that's...
Well, if you think about it, when you first start a cut, that's the only interruption you got. And then when you stop the cut, it's an interruption. So it has limited interruption on a lathe, unless you're cutting something that happens to be interrupted.
Right, a piece of hex or square bar.
Yeah, that's right.
But you picked up this pack of Sumitomo inserts, and they've actually got this...
symbols on the back there that indicate whether those inserts will withstand interrupted cut or not.
Okay, so carbide, which is amazing stuff, sometimes can be less tolerant of the sort of hammering forces.
Oh yeah, typically lathe inserts are not real tolerant of that. Now what happens is inserts that are real hard won't tolerate interrupted cut. Well, you say, well, if I have harder inserts, they're going to cut longer. They'll have a longer service life. So if I'm not cutting interrupted, that's the inserts that you want to use. If you're cutting interrupted all the time, obviously you want to buy some inserts that withstand interruption. And mill inserts are a different grade for that reason.
If you're sitting here thinking, oh my gosh, how do I learn all this? Well, two things. One, don't. I'll come back to that. Number two, we'll put a card in the video to one of the things I really rely on, which is the Sandvik technical guide, and it talks about things like in an insert, you've got two different things that matter: wear resistance and toughness, and they're actually really different things. And we'll dive into that maybe later. But the second thing is, don't worry about doing all this. Part of your job as an entrepreneur or as a machine shop owner in succeeding is building relationships to help you succeed. And I would say, get to know your tooling reps, whether it's Sandvik, Iskar, Sumitomo. Those guys do this every day. Their job is they want to help you. Trust me, they love when they can go back to their boss and say, hey, I found a new shop. This guy was asking me about how to use inserts. He's got an interrupted cut. We're going to get him some chips. They'll probably bring them in on test, which means you don't pay until you figure out if it works. They'll help you with speeds and feeds. It's really the good way to go.
Yeah, that's right. That's right. And so, anybody that'll support you, you want to use them, because the support is so important. They can come in there and pretty much off the top of their head tell you, hey, this is the wrong insert, or this is the right insert, or you can increase the feed on that, or whatever. And part of that's based on what equipment you do have. If you don't have real heavy equipment, obviously you're going to be using positive inserts. They'll know that right off the get-go. Right. So they can get you going.
Cool. So we've got a pack of inserts. This is a Sumitomo CNMG insert. You can see right here. Can you walk us through some of the information that's on the back of not only this pack inserts, but it should be on the back of any insert pack?
Any inserts you have will have some form of this on the box somewhere. Typically, like the top row here where they've got all the colors there, that indicates what kind of material these inserts will cut, or any insert will cut if it has a color designation on it. This one has blue circle there on the one end, which is steel. Each one of those colors means a different material, like the M is stainless and the K is cast iron. So Those indicate the material. This doesn't restrict you from using this particular insert for something else besides steel, but it won't perform as well as it could if it was more of a general purpose, which means it could have more than one of those boxes circled there.
Yeah, and I would say what Paul's saying is right. Sometimes you can get creative, but really if you're getting started or you don't know what you're doing, make sure you talk to your tooling rep or make sure you get a grade and an insert that is endorsed or recommended to cross multiple different materials. And something I'm going to tell you, I'm curious if you agree, but don't mix your inserts. If you take a CNMG that can cut aluminum and steel and you use it to cut aluminum, don't use that insert to cut steel as well. Keep it as an aluminum only tool.
Yeah, I would do that. You know, I mean, you can mark your boxes. Typically, some people put little stickers on there and mark on the box what it's been used for and put it back in that box after you're done using it if you switch them out. And that way you know what it's used for and whether they're used or they're just, I like to keep the boxes when they reorder. If they're a successful insert, so you might want to mark that. If you're having problems with it, you might go, well, they cost so much, you want to get grades that work for you, you know, and talk to your tooling rep about it and get their ideas on it too. But
so what's the circles are?
Now over here to the right of the colors tells you whether it's good for interrupted cut or continuous cut.
Right, okay. So on a lathe, when you're turning like we're going to do today, it
interrupts at the beginning and the end of the cut.
Okay.
You know, once you get that surge when you first cut. So, you know, most inserts, turning inserts will take that, but on this particular box, they've got them designated as light interrupted.
Okay, that's the middle one?
Yeah, that's right. And you see the little black boxes are shaded in there to indicate what they're good for, and you see you got heavy interruption on the end there.
So don't use this to turn a piece of hex.
No, well you could, but you know what's going to happen is going to fail prematurely.
Probably going to crack. So it's interesting. We started with like a $5 $5 loop, and then we ended up buying like an $80 USB microscope. And it's an amazing tool for the shop because you can take an insert like this, it looks perfectly good to the naked eye, you stick it under that and you can start to see things like micro cracking, edge failure, built up edge from material that's been deposited on it, and that's really important to stacking the deck in your favor.
Yeah, that's right. You're keeping it performing the way you want, get the maximum effect for your money. I mean, this particular insert, one reason it's not made for interrupted cut is a finished insert, which is the box down below down there marked with the F.
Okay.
That'll be an F or an M or an R. Okay. So you got medium cutting, finish cutting, and roughing.
Okay.
So roughing would be something that would probably take more interruption.
And I usually think about that as the nose radius, which is, so this is a CNMG 431.
That's right.
The one being the one, it's a 16th thou rad, I think?
Yes, 64th.
Okay, 160, there we go.
That's it, which is about 16 thousandths.
And that speaks to the required depth of cut into the part to activate the chip breaker?
Yeah, you have to get that deep to activate the chip breaker, and that's the other thing. When you've got a finished insert, the chip breakers are different than they are on the other inserts because the chip is typically when you make a finished cut, it wants to come off under like a wire form. The breaker on a finish insert is going to have the breakers made different to try to minimize any bird's nesting, which will break those real tiny little chips. Yeah,
because bird's nesting will, I mean, at a minimum, it can rub and cause marring.
Everything get wound around the chuck and the tools and make a real mess.
Yeah, safety issue too.
Yeah, that's right.
So you'll see a different chip breaker and probably a bigger nose radius on a medium or a roughing insert.
That's right.
Okay.
That's right.
So I find it's very easy to get overwhelmed with the amount of information. So we'll get a link in the video description to one of the things I have found to be the best resource, which is the Sandvik Technical Guide. I would suspect that most insert manufacturers put out an equivalent document. The good news is that most of the stuff, not all of it, but most of it is standardized. So the weird PMK colors are good news that at least all the insert manufacturers adhere to the same standards there. So that guide can walk you through some of the specifics about the materials, the grades. Actually, the grades are probably more brand-specific stuff.
Yeah, the grades are. I mean, they have different letters and numbers for everything they've got. And this has the grade and the insert size marked on here, and this printing here just below these symbols. Over here below the colors is your surface feet and in metric and inches. Of course, this way they can sell them to a metric shop, which might be in Europe or Japan or even in the United States, or inches. If you don't understand metric very well, you can get a real good picture of a starting point or what their recommended starting point is and the minimums and maximums. And this is all based on your cutting conditions, whether you have the machinery to withstand it or your machinery is exceptionally light. It'll help you get through that.
But it's pretty cool. I mean, these tooling companies, they don't just design this stuff on paper. They literally have facilities, and I've heard some numbers about the literally millions of dollars of material that they go through each year. They make an insert, they design their own carbide makeup, they design their own coating, but it could be PVD or CVD, they chip breakers, and then they literally go test and they go build up these cut recipes, and then they put those into this starting recipe. So it gives you the confidence to know this is a really good starting place. It's also probably where your tooling rep is going to help you start out at. I would still say if you're really new or you're really uncertain, get your tooling rep involved, because they are more likely going to be willing to help you out either on the phone or coming by your shop. And then if something goes wrong, they're going to be more likely to help you out or help you get into a different tool. And you can imagine that's a very different prospect than if you just break the insert or break your part and call them up and say, I'm upset it didn't work.
Yeah, that's right. That's right. Yeah, this happens to be a negative.
Okay.
And you notice the sides on this particular insert are straight. So there's no angle on it.
There's no angle in or out. Okay.
Yeah, so then it has to lay in the holder at an angle, and you can see that.
Okay.
Like that. And that's
because you have no relief otherwise.
That's right.
Right.
There's no clearance anywhere. And that gets you so you can flip the insert over to get more efficient use out of all your cutting edges. You can buy a holder to use the diamond sides of these, and that gets you the lead angle.
The chip thinning that we talked about. Yeah, sure.
Chip thinning,
that's funny.
We talked about earlier, and what it is when you enter into a cut, you're changing the length of the chip. You're not changing the depth of the cut. You're changing the length of the chip, which thins the chip, which requires less horsepower. So if you want to get more performance out of your machine, you can increase the feed and still get the same depth of cut.
And arguably you should increase the feed to make sure you're not taking too light of a cut because of that chip thinning effect.
If you thin the chip down, it might not break.
Yeah, right, okay.
Okay, but that also it happens to work on an 80-degree diamond, which enables you to use all 8 corners.
So this is what's awesome. I thought a CNMG, which is a negative tool, it has 1, 2, and you can flip it 3, 4. So I thought, okay, 4 cutting edges. No, it's got 8 because you can get the different holder to cut on the other 4 edges.
The big drawback is cutting up against the shoulder with it.
Yeah, you can't. Or you just can't.
You can. Well, you can, but then you got to come back, dive in there with a different tool to cut that notch out of there. You
could use that as an edge breaker, just to chamfer it. But I guess it's a funny.
Yeah, you can.
That's
but
an
it's
80-degree angle.
Yeah,
right.
It's not exactly 45. Everybody calls out 45s on the edge breaks, but who's going to measure something that's 30 thousandths? But it does look differently if you don't make it exactly 45.
Right.
But that way you can get your efficiency up. But it thins the chip, and it also, when it enters into the cut, when you come into a cut, if this is the edge and you're cutting in at an angle like that, it's easier on the insert because it's easing into the cut. It doesn't, when you take a straight cut like a regular tool, it's a huge surge right off the get-go.
Got it.
So that it eases that a little bit. So that and positive inserts don't take as much horsepower. They're free of cutting if you have a low horsepower machine. You're going to need that. The other thing is don't get inserts that are too big for your machines.
Sure.
I mean, I have, we'll demonstrate a machine that inserts that are number 3s instead of 4s. These are 4. This happens to be a 4, which is
that's the inscribed. So that means you can fit a 1/2-inch circle
inside the die.
Inside the whole thing. Okay, got it.
Yeah, and then it, most people's machines won't cut 1/4 inch deep, that's how deep you can do it with that insert. They don't have enough horsepower.
You can push in. Yeah, that's insane.
Well, the thing about it is, why buy a big insert if you're going to throw some of it away?
Well, and your machine can't make use of it.
That's right. Now, that all depends on the diameter of the part you're cutting.
Okay.
If you're cutting a large diameter, boy, you're not going to, even on this machine, you can't cut real deep cuts. It just doesn't have enough backbone to do that.
Got it.
Well, you can overcome some of that if you go out and get a positive insert. It'll take less horsepower. Well, now you can take deeper cuts, but you lose the extra cutting edges.
Cutting edge, right. Got it. It's a trade-off of cost and time and process reliability.
Yeah, and we'll demo a couple of negative inserts here that are one-sided.
What?
Yeah, specifically designed for heavy cutting.
Interesting.
Which means we're going to overcome the fact that we don't have the other side of the insert by feeding faster
Okay.
and heavier than you could with an insert. See, obviously, when you turn this insert over, you got all those airs. It's not
as stable.
much.
Got it. Right.
Well, if you had it ground flat on one side, now the stability is greatly increased, which increases your capability of cutting real deep and real fast.
Huh. It's interesting. I've seen some of the new, like when we were at the EMO and other trade shows, I've seen some of the new inserts that are coming out that look nothing like inserts we've seen before. They look like almost like these little ninja stars that have all these different geometries. And I think part of the reason of that is they're getting more cutting edges out of the carbide and they're keeping it more supported as you index through the edges.
Yeah, I think the last video we made, we discussed some of the insert holding capabilities of the tools. They look different. We can go over that again a little bit today. If some of these inserts, the way they're held in the holder is a good indication of how much the holder will take. Not only the insert, but the holder. I mean, some of the clamping mechanisms are not that substantial because they're not designed for heavy cutting.
Right.
But it might be designed for evacuation of greater evacuation of chips and better access to coolant.
Yep.
That's the other thing. I mean, coolant will increase your depth of cut. You can cut faster and heavier, and not only that, you can measure the part when you're done because it's cool to begin with.
That's a big deal. Using carbide correctly, you are going to dump heat. Heat gets created, and you want to get that heat out with the chip, but your part is still going to warm up. Folks, it is amazing. You can literally move parts by more than thousandths of an inch as they get hot.
Yeah, so you don't want to do that, especially if you're doing highly accurate work.
Right.
Yeah.
My other advice too is if you can, when you're buying a tool holder, and if you're new or you're not sure what you're doing, is the tool holders that have I call it like the sacrificial pad below it, it can really save your butt because you may spend $100 or $200 on a tool holder, and if you crash it or make a mistake, which it happens, it just happens, you're going to replace that pad versus ruining the whole tool holder.
Yeah, I mean, less expensive holders don't have the seats in them.
Is that right?
Yeah.
Okay.
Which means just what you're saying, if you blow an insert, you've just thrown away the whole shank.
Yeah. I mean, we had a goof happen last week, and it wasn't our fault. We had a screw back out of a fixture, and the inserts hit it, and it shattered the insert, and the pad saved us. So that's a good thing.
I mean, if you look at this insert, this doesn't have a clamp on the top. This is a Sandvik. And they have like a hook-shaped piece that goes down inside here, pulls it up in here and holds it down.
Interesting. That's got to be lighter holding duty than the over
it's a lighter holding duty, but you see, if you've got coolant blowing on that in a CNC machine, there's no interference or anything, so it can. You got a double-edged sword there, and I like them because they're easy to take the insert out of and put the insert in. There's not two screws to mess with like this particular holder here. Has a clamp, and then you got to get underneath here or here and knock the cam loose to get it out of there. You don't have to deal with that with this. You got one screw and you're done.
Got it.
But just like you're saying, you can't cut, that's heavy.
Yeah.
Okay, and then you take these like this is a single screw, which is weaker.
Yeah.
But you'd be surprised. See, this is a positive.
Okay.
You'd be surprised how heavy you can cut with that thing.
Huh.
And you know,
I guess the good news is that it's intuitive. When I see a holder that's got a big, strong clamp pushing down over top of it, that's going to be more rigid than something where it's just kind of a swelling around a center hole.
That's right. It doesn't. You don't have the same effect.
Cool. What do we have up for today? We've got two different pieces of stainless, 303, 304, despite only being one digit apart, very different materials in my limited experience. 1018, which is probably the most common steel, at least cold rolled steel that I see. 1045, but 1045 is just a slightly higher chrome content, so a little bit stronger, higher tensile strength.
Yeah, a lot of people use it for forgings.
Forgings, interesting. 4140, which is also sometimes called the chromoly, a pretty decent steel alloy, I should say, that can be
heat treated, but it won't go all the way up.
Won't go all, meaning the Rockwell caps out. So.
Yeah, there's limits to how hard you can get it.
Got it. 12L14, which is probably the easiest free machining steel because that L means it has some lead in it. Although, fun fact, don't think that because other materials have L in it means that's also lead. I learned that the hard way. Was it 304L is not leaded stainless. But 12L14 is, you see that a lot in industry?
Yeah, you see it some, but not nearly as much as you used to because of the lead content.
Yeah.
People want to get away from the lead, so they use 1215 to get away from the lead.
Okay.
That way they don't have their employees exposed to it.
That seems, okay, well, so is 1215 a similar free cutting?
Yeah, it's really free cutting steel. It's about as free as you're going to get. Go ahead with the cast iron.
Yeah, so class 30 and class 40 cast iron, which I know nothing about.
Yeah, this is what people term as dirty.
Okay.
This is about the nicest cast iron you're ever going to get.
Is this ductile?
Some people classify it as ductile, but you can get a higher grade iron in it. And when it cuts, the chips come off. They're similar to steel. They're not quite like steel.
This is the stuff I hate.
Yeah, that stuff just chips off.
Like sandpaper, muck, yuck.
Yeah, that's right.
Got it.
But it's real easy to cut, but it's abrasive.
It's abrasive, right. So that's actually a really good point. It's abrasive, which affects your cutting tool life, but also you don't want to be grinding that stuff in between your ways and gibs.
Yeah, you definitely want to clean things up. There's shops, that's all they cut.
Yeah.
You know, and a lot of people are moving away and moving towards the class 40 because it's so much nicer and the parts come out, they're stronger.
Okay.
And to machine it out, they'll buy a billet like this. This is typical what castings would come in, but like I told you the last time I think you were here, a lot of lathes are made out of class 40 so they can flame harden away.
So that's the induction hardening.
Yeah.
Actually, really cool process, folks. Card here when we toured Tico and we got to see them flame hardening a vise body. Really cool process, and this stuff can actually get pretty darn hard.
That's right. That's right. Well, the one thing you want to pay attention to when you're selecting steels for any particular project, you want to pay attention to that. What kind of characteristics do you want? How easy is it to cut?
Yeah. I mean, my go-to is this because it's cheap and free. Well, I shouldn't say it's cheap, but free machining and readily available. This because it's just so darn common.
Yeah.
Maybe a bad reason, but it's just
that's right. And if you cut much 1018, it doesn't finish nice.
Yeah,
it's hard to finish. That's right. It's really hard to cut, and it's roll finished. And cold finished is basically what they call it, and that's why it's kind of like a cold forging process. Okay. This stuff, is real easy to cut, but it wears easy.
Yeah, it doesn't have the strength.
Yeah, it doesn't have the strength. Now you can have it carburized and get it cased.
Case hardened. Okay.
Yeah, but if you want something that cuts real easy, this is fine. But if you want some wear resistance, then you're going to select one of the other steels. You need to pay attention to that. And of course, along with your cutting tools and everything else.
Right.
You're trying to get everything to go into concert with each other. But this is a variety of pretty common stuff that you use. I mean, we could get harder steels, but I think most people, this is what they're going to be using. Most of the time, like you say, cold roll is very common.
Yep.
But if you're trying to get a nice finish, 12L, boy, once you've used that and you get a real nice finish real easy, you go, I don't know if I want to go back to cold roll. But, cold roll is nice and tough.
What do we have over here, Paul?
Those are made out of 4140.
40. Wow, those are some nice parts
for the fracking industry.
Okay. Wow.
That's 4140 heat treated.
So that's 30 Rockwell-ish hard?
Yeah.
Wow.
Yeah.
Beautiful finish. I mean, seriously, that's beautiful. And those threads are incredible.
That's a number 3 Acme.
Number 3 Acme. Wow.
Yeah.
Holy cow. And so they come into you like this and you're doing the...
Well, what they typically do is they have a piece that's longer than that, and we do the same thing to it. And when the ends wear out on it, we cut the ends off and cut it down into shorter ones.
You recycle it into
That's right.
Interesting.
That's right.
Very cool. So you do that on the machine we're going to be using right now. Very cool.
That's right.
Awesome. All right, let's make some chips.
Yep.
We keep saying that. Is that a cast?
This is a cast iron chuck.
Versus a steel chuck is your other option?
Yeah, me personally, I'd prefer a steel chuck because they're much higher speed.
Higher speed? What do you mean?
You can run them a higher speed.
Because they don't flex?
Yeah, they don't recommend these to be running over 500 or 600 RPM.
Really?
Yeah.
Wow.
Because cast iron is just not that strong.
Wow.
If you have a steel chuck, and not semi-steel, steel.
Yeah.
There's no voids in the back. It's drilled in the back instead because
Okay.
it's been made out of a solid chunk of steel.
Got it.
They'll run way up.
Yeah.
Which is nice because in a shop like this, you can run smaller material and get it to run faster. The only problem is steel chucks are not cheap.
Yeah. But this lathe, I would think, has a couple thousand RPMs.
Yeah, this is 1700 is the maximum on this thing. And it's like I told you before, the 20. This is a 2060.
2060. Okay.
Yeah, 20-inch swing, and of course this has a gap. We can get up to 27 or something like that.
You don't pull the gap though, right?
Yeah, I have.
Oh, have you?
Yeah.
Okay.
We had some parts in here just barely fit on this thing.
Even with the gap pull?
With the gap out, yeah.
Wow.
But 2060 is the most common size because of the horsepower combination and with the RPM and this rigidity of the machine.
Yeah.
It's a real popular size for that reason. You can do small work on it. I don't like doing small work on this because I have a smaller lathe.
Yeah.
You get spoiled because it's not hard to move things around on a smaller machine. Bigger machines work.
Yeah.
But this offers the real good combination of horsepower. 24 inch is not bad either, but most people that have a backyard shop are not going to have that.
Right.
Have a little machines, but I think I said that last time too. 1440 in my mind is the best size you can get.
1440. That's a lot smaller lathe than this one, though.
Yeah, that's right. It is. I mean, and I have to admit that you would struggle to get a 1440 in your basement.
Yeah. Oh, yeah.
You're going to have a garage and a phase converter, and you're making a major commitment. You're not getting a toy. And a lot of these machines they sell online these days are made in China or toys.
Yeah.
They're not really meant to do much.
You always use a 4-jaw?
The reason you use a 4-jaw, it's the most accurate chuck you can use.
Yeah.
You can indicate way down.
Yeah.
Just as accurate as the machine is going to be. You can indicate that close. 3 jaws, the problem is if you got to use one, 100% of the time it's been abused. People will hold clamp stuff way out on the jaws, and that makes the jaws buckle out like this.
Okay.
Then they don't want to clamp right because the jaws are like that.
Sure.
Then you have problems with parts coming out of them because they don't want to hold right.
Yeah, that's not okay.
And I'm sure numerous people have had that problem.
Huh. And because it's a scroll, you don't have the individual.
Well, that's right. That's right. On a 4-jaw, when I tighten this jaw up, I'm really making it tight, and all the force is going into this jaw. If you take a 3-jaw or a 6-jaw, whatever I crank on this is divided by that number.
Yeah, so if you guys have never seen the insides of a scroll chuck, a typical 3-jaw, they technically have other numbered jaws, but there's a whole scroll plate inside of here. So each screw is distributed across that whole. You're just rotating that screw, that scroll around, and so it's distributed across. And
that's right.
You've got run out in the scroll or debris or material, or the teeth are worn.
Yeah, there's several. I mean, to get a 3-jaw really accurate, you want to put soft jaws on it.
Yep. Okay.
And bore the soft jaws, and then you got to be careful about you need to have that right on size with the size you're clamping, or a little under, because you don't want it clamping on the dip in the jaw. You want to clamp it out here on the 2 points out in the jaw, and that's the way to get a soft jaw to cut really close, the hold really close, the indication really close, and of course that's what they do with CNC lathes all the time. The big advantage a CNC lathe has with a 3-jaw chuck is you got hydraulic power.
Oh, you just power
behind
through
that thing, and you can clamp. It'll squeeze a piece of steel like a rotten banana if you want it to. I mean, but it's not like a manual machine like this. If you got a 3-jaw, you can't cut it very hard.
Interesting. I always hear about the lack of run out, but not the clamping power.
Yeah, the clamping power is not that good, and also a 3-jaw is, it's 120 degrees between jaws, which means there's more room for this thing to buckle around.
Interesting. Yeah.
You're not holding as many. Now that's the advantage of a 6-jaw, but the big advantage of the 6 jaws is you're trying to keep the part round, so you're distributing the clamping pressure all the way around the part. That's the beauty of those. They're really meant for holding stuff that's fragile, and you don't
like
want
thin wall pipe.
Yeah, and you don't want to warp it or whatever. I mean, I think you did a video a while back where you had a little.
Oh, we don't have to bring that up. Yeah, I crushed blue tolerance because I crushed the part even in a 4-jaw.
Yeah, I mean, if I bore this out even just right to here, and make it relatively thin, and I part it off, it'll show up.
Yeah, that where you were holding it.
Yeah, that's right. It'll show up on the thing.
It's almost scary to say. It almost reminds me of when you're on a surface grinder and you start using residual magnetism. You kind of back that pressure off to take the work holding out of it.
Well, believe it or not, you do that here too. You can rough this thing out, release the chuck, and remachine it.
This is why I hate lathes.
Yeah, and it will make it way more accurate that way.
Wow.
You can get all the run out of it. You can get all the warp out of it. You can get everything out of it. You want to play with it.
Wow.
So, you know, and that's CNC machines are different that way. You know, they want to get a net shape off of there.
Yeah.
And I think some of them can control the chuck pressure. You know, it'll run so much, and then the chuck pressure will drop, and then they can rerun it.
In the operation.
Right. Yeah, that's
Holy cow! I never thought about it. Makes sense.
Yeah.
Wow.
So you're not, you know, squeezing it so hard that when it comes out, it's undersized.
Right. Right.
Or oversized.
Yeah. It's probably over. Yeah. It depends on which diameter you're cutting.
Yeah, that's right. Huh. That's right. And of course, you can clamp here very tight, which is really nice. Because then we can hog like crazy, and that's what you'd want to do if you were machining this down thin. You'd want to hog it like mad. Yet that's the other thing. When you start any project, you want to look and see how much metal am I taking off. Am I taking a lot of metal? Where do I have to take the most metal off? Okay. Well, that might be the end that I want to start on, so I can hog like crazy. Yeah. And then the other end might be a light cutting, and all I have to do is turn around and do the light cutting, and I can't take the wrong end and do the roughing on the second operation. You can, but that's going to slow you way down because you can't grip it. So you have to think about that when you're doing that. Also, if you're center drilling, if you have a drilling operation on here, you might, we'll start out with a W. You might want to at least put a center drill hole in here.
Yeah, so you're not running the surface footage
to
zero.
So, well, if you want to face off, facing down on any diameter, it's obviously you're running real fast on the outside and you're running real slow. The smaller you go, the slower the surface foot's getting. And man, that puts a lot of strain on a cutting tool. Now on a CNC machine, obviously the machine accelerates. You have constant surface foot. It'll maintain it, but it still has that problem even when it gets all the way up. It's practically not turning when it gets to the center. Right. So if you are able to center drill this because it has a hole or it has a center in it, if you do that first, then you can see it face down to zero and not damage your tool, or at least be less likely, because it's not going to be, unless you have my CNC lathe goes up to 5,000 RPM. A lot of smaller lathes will go up to 6 and even 12. Yeah. Some of the screw machine type machines. But it's still, if you look at it under a microscope, that center is not turning very fast. And that has a tendency to want to chip your insert. You don't want to do that.
Folks, this is the Ferris wheel at the fairgrounds example. When you're on the edge of the Ferris wheel, if you look down, you're covering a lot of ground underneath your feet. That's what's happening to the lathe tool when you're out here. But as you go to the middle, if you're standing on the axle in the center of that Ferris ground, you're literally covering 0 feet underneath you. So you're pushing a chip, you're not shearing. So Paul gave me a really good piece of advice like a year ago. Even if you have to create a 5 or 10 thou deep spot drill on the center of that part, you're going to actually really improve tool life, tool wear, surface finishes.
Yeah, that's right.
The world becomes better.
Yeah, that's right. The finishes will get better because when you keep facing parts off, they're not going down to 0 all the time. And even if you take and center drill it and you almost face it all out where nobody can even see it, you're still saving a damn point on the tool. Excuse me, my language. But anyway, we're starting out with a W, and this one here happens to be a 3.
Okay, smaller. Yep.
Yeah, this is a smaller insert.
Did they make a 2?
They might. I think they do make a 2.
Okay.
They make 2s in triangles.
Like the T's?
Yeah, the T's. Okay. This is a W, and this is a 3. So we can go 200 thousandths on the side.
Because it's 375, so technically 3/16. Yeah, sure. Okay, I'm with
you.
That's crazy to think you would go 190 thou or 200 thou depth of cut.
Yeah.
That's radial.
Yeah.
So you're taking 0.4 inches off the material.
Yeah, that's right.
Wow.
Yeah. So that way you can.
We're gonna do that?
Yeah, we can do that. It'll be easy on this. This is 12L14, man. This is as easy as it gets. Now, I have a rule in shop that I learned this where we used to work, and it's a really speed your operation up a little bit.
Okay.
When you set your feeds, okay, you want to jump between feeds. You want a finished feed, a medium feed, and a roughing feed. So what you do is you want to select 3 feeds on here that are easy to jump to from one to the other, so you can make those connections. You can say, all I have to do is flip this one handle and I'm medium, and I can flip it again, I'm in rough, and I can flip it again and I'm in. So what you do is, typically what you do, I do, is I'm using 5, 10, and 21.
That's feet per, that's thousandths of an inch per
revolution,
okay.
Yeah. 5 thousandths, 10 thousandths, and 21 thousandths.
So you pick a gear ratio that lets you flip between those two with just one handle.
That's right.
That way you're not going...
And this particular machine is right here. It's 4, 3, 2.
Yeah.
And even 1 will take me up to 2 thousandths feet.
Ooh,
per
that's
revolution.
light.
Yeah, that's right.
Okay.
So all I have to do is shift from these.
Yeah.
And I don't have to go over here and keep changing gears around. Yep. And that gets you into range where you say, well, I'd like to have a 32 finish. Well, you can drop down to your number 2 in this case, which is 5 thousandths, to get your 32 finish. And
32 RA.
Yeah, that's right. And, or you can go up to 10 thousandths and maybe get a 125, and then you can get a 250 on up to the rough, and you might want to keep it up to rough just to keep cutting roughing. And that way you don't have to keep flipping everything around. Now, in this case, and this is true of a lot of lathes, when you shift to facing, it splits it.
Oh, is that right?
Yeah, that's right. You know, so the roughing is actually 10 thousandths.
It's half.
That's
Okay.
right. Everything's cut in half.
Huh.
So you have to keep that in mind when you're doing facing, because that affects your inserts. So, you know, the inserts are affected by the feed and what kind of insert they are. So
it's funny, the number one insert and tooling mistake I've seen with folks that are new to this is really running too light, rubbing or not. The tool, I would hate to say it, but if someone's going to make a mistake, I'd rather them say, man, I was taking too much depth of cut, or I was cutting too aggressive. Usually I see guys just baby it, and it causes problems, and it can ruin an insert.
Yeah, well, it's like we were talking about earlier when we were talking about the inserts here. They do give you a starting point. You can start at the low end if you want to. If you're a little bit apprehensive about saying, wow, that is really fast, or that's a heavy feed, or well, start on the low end.
Yeah, so, but still, if you take a 1-inch piece of aluminum, especially, no manual lathe is going to have the speed RPMs, and frankly, it's not even safe on a manual machine.
You're better off to run a little bit slower and just try to get, like we've talked about a little earlier, get some support from your tooling salesman, and he'll get you an insert that'll cut it at a slower rate.
Yeah,
and you might have to use a little bit of coolant to keep it from sticking.
Yeah.
But that's what you accept that based on what machinery you've got available to use. So we'll bring this in here and we'll fire this thing up. Okay, we're gonna try a couple feeds here, and we'll try to stay in the same range on all of them so we can see what the difference is.
Awesome.
So I have already explained the range of feeds that we're using. So we'll start out, let's start out light, and we'll start at 5 thousandths.
So that's 10 thou per rev, but you're facing it. Right?
If you're turning it, it's 5 thousandths. If you're facing it, it's only 2.5.
Oh, 2.5, okay.
Yeah. So we'll take a... you see, that's 5 thousandths. And it's a nice little seed chips here, and they're real light.
Yep.
Okay, and it's chipping, and that's what everybody loves about 12L14. It doesn't take much to make it work nice for
break the chip.
Yeah, that's right. So now we'll take it up to 10,000 speed.
Smaller chip.
Yeah, so what it does is close the C up.
Closes the C up.
That's right. Okay, now we're going to do 20. 20. Let's try, well, that's the same RPM.
Almost too tight.
Yeah, they get tighter. Okay, you can see how they're even tighter now.
Well, really, it's almost too tight, right?
Too tight there.
Yeah.
Well, you could use a different insert.
Okay.
Okay, that was 400 surface speed.
That was?
Yeah, all three of those cut was 400 surface speed. I'll slow it down a little bit, see if we can keep it from the chips from bouncing around so much. Now you see that's a little bit slower surface speed. 21,000.
They're a little more open. Mm-hmm. Man, you were wailing on that though.
Okay, now run both of them. Now we'll try a maximum cut for this insert,
which is almost 200 thou radial.
200 on the side, so it's 400 thousandths on the diameter.
Wow.
That's the maximum that insert will take. It'll probably feed a little faster if we wanted to.
What feed is this?
This is 21.
Oh, yeah.
Okay.
What's the surface footage?
300. Now I had it running a little faster earlier, but that makes it, the chips bounce around a lot more. So if you're trying to run a machine this way, you got a little more control over the chips and you're not getting them on you so easy because they're 400 or 500 degrees, and that gets a little bit tough to handle if they get bouncing on you. So that's all with the W, and of course the W you can face off with. I typically bounce the RPM way up when I do facing, so it's too fast out here, and then it won't be so slow by the time it gets down to 0.
Okay.
And you can get that to chip the same way. Okay, so I can take this on up to
whoa, those are really hot.
Yeah, they'll work better with coolant when you do that.
It's hot because of the surface footage out there?
Yeah, that's pushing the limits of it. But as you get in slow,
it'll slow down.
It's going to slow down. Now, that can damage your insert, but it's a good idea to run coolant on it, which we're not right now. And you see it's chipping out the same. We're not making a whole lot of mess, but that's the luxury of 12L. We won't have that luxury with some of the other materials. Yeah.
All right, well, why don't we see how that compares to 1018?
Well, we'll go ahead and you want to go ahead and run a couple different inserts and see how they work relative to this, just while we got this up here.
Sure.
So we'll take this out. Okay, we're limited on this insert because this is a number 3, right?
Yeah.
What happens when we put one that big in there?
It's a T, that's a 4 size?
Yeah, it's a triangular?
Yeah.
You think that's a 4 or 5?
Oh, 5, yeah.
Okay.
Half inch, sure.
No, 4 is a half inch.
Wait, what's a 5? 5/8?
Yeah, that's right.
Holy cow.
So we can go 300 deep. So we can take, we're at 20 right now.
Whoa.
And if you remember, this is a single-sided insert.
Yeah. Oh, so
it's designed for heavier
but it's still,
cut.
is it negative or neutral?
Yeah, this is a negative.
Yeah.
So you can see the depth, the maximum depth we took on there. Now we have another insert. This is a T. This is another C, which is wavy looking, like John's familiar with, for these aluminum inserts.
Okay.
This is specifically designed for high feed turning, okay? This is also one-sided.
Interesting.
And it's designed not to use much horsepower, but cut real heavy.
Holy cow. Oh, that's insane. I can't touch one of those.
No, if we can probably pull that down a little bit. Let's see if it'll.
Holy cow. Okay, so the second cut was a little better. What did you do on the second cut?
Slowed it down just a little bit.
Surface footage.
Yeah, that's right.
Because that's a 6, but you've got too many coils.
Yeah, that's right.
Well, you're going to catch the paper on fire.
If you slow it down a little bit and the feed stays the same, that's still 20. This insert will do more than this machine will do.
Wow. Holy cow. 21 thou per rev. Half inch depth of cut or so?
Yeah, on
400?
that one, yeah. This is 300 on the side.
300 radial cut. Wow.
Now, a lot of people's machines won't do that because
Right.
they don't have the horsepower
Right.
or anything else. But if you get a machine like this is a 20 inch, if you get a 24, this is probably 15 or 20 horse. It'll do that. And you know, you've been to machinery shows where they can cut really heavy.
Yeah.
If you try to push this machine that hard all the time, it might not take it.
Got
We
it.
do that intermittently here.
Yeah.
This is not a 100% duty cycle.
Right.
You
Right.
know. But
That's impressive, though.
so we did that. Now we've done the high feed, we've done the T, and we'll do a positive insert in a round.
Ooh.
How about that?
Okay.
See how that looks. Now the advantage in the round insert, of course, you get a radius in the corner, but you can feed these real fast and get a good finish.
Yep, right.
Let's go 300.
Holy. Beautiful finish. I never think about it as, I always think about it just coming into a corner, but
Yeah, well, if you think about the way your tool cuts, you know, you're getting a zigzag like this where the tool meets there. If you have a radius, it flattens that out. And of course, this is a free cutting insert because it's positive.
yeah. Beautiful finish. Warm?
Oh yeah.
Beautiful.
See, that's a positive insert.
Wow.
So now, a lot of people use these like this. I don't know. Well, we can show this. Okay, you can set one up for turning is what I do. And you can set one up for facing. See, and they'll cut the same because you can just put this in here.
And you walk
face
across
off.
it.
Yeah, and face off, and then you can just, this way you're using twos and do this for turning. Now these won't take turning like we just did as much, but they're great finishing tools. And this way you got the same insert in both of them. You don't have to buy a whole bunch of different inserts.
Yep.
Now the W, you know, it turns and faces, but you can't get that nice point down in restricted areas. Okay. If you want, we can change the material.
Yeah, let's try it out.
Okay, now we got the 1018 up here, and we're going to take the same cuts on this with the same tools. Pretty much the same surface speed. We'll start out, let's start out with 5. We'll start out with 5 thousandths. And it's not chipping too bad.
It's cool how the chip is rolling down.
Yeah, which is okay. This way you don't have it splashing on you.
Yeah, it's
I
nice.
mean, you can control that by the feed and how fast you're running the RPM or the surface speed, I should say. This particular insert is pretty chip break friendly. That's one reason I've got those. So that's 5 thousandths. You reach down there and change it to 10. You see it, the C's are a little smaller.
Okay, slightly smaller chip. Same color-ish. Should be dumping a little more heat into it though, right?
Yeah, that's right. We can do that and there's 20.
Woo! You can see just the velocity, the speed they're coming off is even higher.
Yeah. So now we'll do Okay, now we're going to go to the maximum depth on this
Okay.
tool. Let's try it at 5. And you can see it's not breaking it at 5,000. Okay, we don't want that. This is 10. Ooh, still not breaking.
Nope.
Okay,
Wow.
so you don't want that.
I'm sorry,
This is typical of cold roll.
took the pliers. Yeah.
Okay. Some people are familiar with that.
I'm very familiar with my bird's nesting.
Yeah. And that'd be severe like that if its depth of cut's really deep.
So how do we fix that? Faster?
Increase the feed.
Increase the feed, huh?
Yeah, you can increase the feed and decrease the speed, or both. We'll try increasing just the feed.
21 thou?
Yeah.
Oh yeah, that did it. Wow.
You see how it's transferring the heat over? And there it is.
Look at the
see.
chip. Beautiful chip.
Okay, breaks it up, and it's just a perfect seize.
That's reminded me of A-Bomb 79 chip right there. Blue, small. I don't want to touch them. They're you
Yeah,
you can feel the heat.
But if you
Oh
put your
my
hand
God.
up here, feel that.
It's not hot at all.
No, it's transferred all the heat.
It's transferred
into-
all the heat. I mean, literally, that feels like a fire right now.
Yeah, if you run coolant on there, there's steam coming off of it.
Yeah. Holy cow.
Yeah, so now,
Wow.
that's at 21 thousandths. We can switch tools. Let's go to the heavy cut tool. Okay, we're at 21 thousandths.
Not as hot a chip. Interesting.
Yeah, that's right.
You can see the chip is more of a brown, not a blue. Are you going to let it run into that shoulder?
Yeah.
Whoa.
Now,
why did it
string a little bit?
Why did
Well,
it start?
because constantly cutting edge is constantly changing, and evidently we're at a break point there
Yeah.
where it's just changed a little bit and it made a difference. So
A huge difference.
in order to keep it from doing that, we probably need to feed a little faster.
Even faster.
Yeah.
Wow.
So that is that.
What insert were we using there?
This is the T.
The T, okay, the triangle.
Yeah, the heavy triangle,
Yep.
okay. Now we're going to go into the heavy cut, which we might not be able to get this to break with the cold roll, I don't know.
Oh, it's breaking. Yeah. Yep.
They're a little bit, look like they're coming off pretty good. You see the finish behind it there?
It's a great finish. My
Yeah.
gosh. Well, what insert is that again?
That's a CNMG.
Okay.
It's
That's-
just a one-sided, super high
Really?
feed insert.
Interesting. Boy, it loves. That's the best. That's a great finish for 1018.
Yeah, that's right.
Who makes this? Do you know who makes that insert?
Sandvik.
Is it Sandvik?
Yeah.
In a Kennametal holder.
Yeah. Well,
Wow.
Yeah, that was commonly used where I used to work. They used a lot of those.
Interesting. Huh.
And for that reason, they can move a lot of metal in a hurry.
And I can't get over that finish. My gosh. It's like a mirror for a material that's.
Yeah, well, if you feel it, it's got feed lines in it because it's about a 125 or
RA.
yeah.
But
because we're feeding
still-
so fast. Now you can get a better finish if you take.
So then
Now we'll take this and see if we can get this to do anything.
Yeah.
You see it's coiling, so it wants to feed faster.
Are you already at 21 thou here?
Yeah, that's right.
Yeah.
We can feed faster than that, which would make it dip the way it was. That's not terrible, but you know, now you got bigger pieces flying around, and that's not.
Yeah, those hurt. That's a lot of weight to that chip.
Yeah, that's right.
I mean, that's really too big a chip for a
Yeah.
I would think that's
For most people's machines. And now see, you can get coils like this. I'll show you one that we have hanging around here for. Yeah, see, you don't really want a chip like that.
You explained that you made this for demonstrative purposes.
Yeah, that's right. Yeah. That's right.
This was intentionally done.
And that's not. It typically happens when you don't want to. Sometimes when you're trying to make it to it, won't do it.
Right, right.
But I mean, this is not real burry or anything, but this is what you don't want because this gets on your feet, and you can step on this and it rolls like a bearing. You don't want that to happen.
Cut your arm off too, Paul.
Yeah, it'll burn the dickens out of you if it gets on.
Yeah, no, that's a real safety issue.
Yeah, that's right. So. So now we've cut 1018, and it was used the same tools, same feeds.
A lot harder.
But I knew that this particular material has to feed harder to get it to break.
Feed harder to break. So what's the 1045 going to be like? Easier to cut or harder?
Yeah, it's actually a better cutting steel than the 1018.
Interesting.
Yeah.
Why?
It's just the makeup of the steel.
Okay.
Some elements they put in there makes it more brittle.
Okay. The higher tensile strength means it shears.
That's right.
Better.
That's
Interesting.
Right.
Yeah, 1018. It's funny because it's a steel, but I have heard people say it's gummy or soft.
Yeah. It you know, my biggest problem with 1018 is it don't finish.
Yeah.
It doesn't want to finish unless you can run it up fast, and that's
that does
one reason you bring a 6-inch in here, because you bring smaller material, boy, you got to wear it up.
Yeah.
To get it to finish, which the CNC machines do beautifully.
Yeah.
You can cut some pretty. If you're cutting real small 1018, you got to have some real RPM, and that's why you have to study the materials that you're going to use for any particular project. I mean, I know a lot of guys. You'll have a scrap box with a lot of material thrown in there. Try to be conscious about what you're throwing in there and make an effort to mark it or have separate boxes for separate materials, and that way you can heat treat it and get end results. There's nothing worse than building a project and wanting to heat treat it and it's the wrong material and it won't heat treat.
Didn't realize it. Yeah.
Yeah. So you want to keep those things separated. It's not only that, it's what I'm cutting. What am I cutting? Well, I've got a lot to cut off, and it doesn't really reflect on the finished part. I might want to buy something that's easy to cut, it's not hard on the tools or the machine, and I can remove the metal quickly.
But a lot of guys getting started, we want to make parts that look nice, so I would almost say stay away from 1018, go to 12L14, or step up to your 1045. A machine, you can cut 1045, it's not that hard.
No, it's not.
You're going to get a better finish, which means you'll feel better about your parts.
That's right. Yeah, that's right. I mean, 1045 finishes nice, 4140 will finish real nice.
Yeah.
Anything that's hard will finish nice, but also you have to have the right cutting tools.
Yeah.
They can be hard on your cutting tools, and if you don't understand it, like if you want to chase threads. Well, in this particular machine, if you're wanting to chase threads, if you use carbide inserts, well, obviously you can't get the speed that a CNC machine gets, so the efficiency goes way down on your insert.
Got it.
Fortunately, a lot of threading inserts are designed to cut slower.
Interesting.
Mainly because even your CNC machine can't back out fast enough.
Right.
And they designed the inserts around that.
Got it.
So for that speed problem. And also you got fancy inserts that'll cut the top of the thread.
Toppers.
As well as
Love those.
Those are really nice because you're not rolling the burr up and all that stuff. But that can be expensive if you're cutting a variety of.
Well, yeah, because the topping inserts are dedicated to
one pitch. And that's it.
Right.
And sometimes it's difficult to chase up against the shoulder because of the way that the insert's designed. But if you're designing the end product, you can design around that.
Yeah.
Okay.
Now I'm excited to see what the 1045 looks like.
Okay, we'll get that put in here next. Okay, now we got 1045.
Back to the W insert.
Yeah, we got the W insert in. We'll take 5,000s cut, 100,000s deep, 5,000s feed. This is compared to the other cut we had.
The finish already looks great.
And it's coming off there a a little harder than the other ones, breaking up a little bit more. So let's take a little bit. Shift it to 10.
10 thou per rev now?
Yeah. I think it gets up there a little bit.
Now, does it really require that much more horsepower than 1018?
Not really. As far as horsepower, this and 1018 is going to be about the same.
Okay.
Yeah. Some people refer to 1045 as cold roll, but it's not.
What do you mean it's not?
It's not a cold finish.
Okay.
Hot finish. That's 10,000 speed. Jump it up to 20, see what it does.
20 thou.
Chips are coming off there hotter.
Wow. Sounds like the lathe is straining a little bit.
Yeah. And you notice this has slag on the outside too.
Okay.
Which, when you have slag, they have what they call notching.
Okay.
And where you have the slag on here, it'll actually cut a groove in the insert.
Because of that hardened scale finish?
That's right.
Huh.
So you can buy material slagged already.
Where they actually cut it? Or?
Yeah, it has a rough turn finish on it.
Really?
Yeah, and taking the slag off for you.
I gotta think that's a lot more expensive because someone's processed it.
Sometimes it is and sometimes it is. Depends on where it's coming from. Some of the overseas steel is already slagged and it's cheap.
Interesting. Do you pay attention to your certs when you order material and where it came from?
No.
Yeah. Okay.
If you're a defense contractor, you probably should.
Sure.
But they have handheld spectrometers now. You can check it.
Wow.
So you can hold it up against there and see what's in it.
We had some bad aluminum, and I actually got the cert out, and it was Asian, and so we've started speccing only U.S. aluminum.
Yeah.
Just because it's not that much more, and I don't want to deal with fighting somebody on a return or a piece of aluminum that's a potato chip.
Yeah, that's right. Yeah, I mean, you're pricey. You're making a sacrifice somewhere.
Yeah, right. Sure.
So we've got this all the way up to 20. We'll take one of the bigger roughing inserts and put it up there and see what it does. Okay, we're back to the T. Super big insert. Now this machine probably will have trouble pulling this. It might. I think it will pull this.
That says 20 thou per rev? 21 thou per rev?
Yeah, 21 thou per rev.
With a 300 depth of cut? Holy cow. Oh my God.
Good looking tip, and you see how it's pulling real tight. The C's are real tight on that because of the zero part.
It seems okay.
Yeah.
Okay, question for you. When we talk about the chip forming a C, literally the letter C, does that happen? Is the chip more of an open shape when it's actually cut and formed, and then the heat causes it to curl in on itself? No. Okay. So it's that C is occurring
cutting process
at the fracture edge.
Yeah.
Okay, got it.
And it's a question of what state does it fracture in? You're trying to force it to fracture so you don't get those big long chips.
Yeah. Okay.
And that's, you can see these are real tight.
Yeah, super tight C's.
Yeah,
And
so you wouldn't have to
glue.
feed as fast as we're feeding to get it to break.
That's a great lesson. So when you know you could back it off a little is when your C's are so tight that you've got you could back that off and still not get burst nests.
And that's right.
Okay.
And of course, that means you're not going to be cutting as fast, but you
Yeah.
might be able to cut deeper. So you have
Cut
fewer
deeper,
cuts.
yeah. But I would care, I mean, again, I'm not a production shop. I would rather avoid the bird's nest than try to shave a minute or two off of my cycle time.
Well, you know, it depends on, you know, like this particular insert, to get maximum efficiency out of it, you have to cut deep. It's made for cutting deep, period.
Yeah.
So if you're not cutting deep, you're wasting the insert. So
That I
you don't
hear
buy
you.
this insert, or you buy a smaller insert.
Smaller
if you're not
IC.
gonna- yeah.
Yeah, which is a lot cheaper of an insert.
That's right. And that way you get everything you can get out of the inserts you're getting, and you're cutting the way you want to cut.
Fair enough. It's a good lesson.
Okay, we got the
Oh.
high feed insert.
The CNMG that's got
Yeah.
a solid floor.
That's right.
Oh man.
Let's see what this will do in here. I think it'll probably handle that much.
Woo!
See that? It's too much for the machine.
Wow.
Let's cut some
Now
of the...
wait, you were doing that same cut with the T.
Yeah, sometimes they react different, but this one right here will cut some of that jump off of there.
No, but Paul, that's really amazing. That T insert was able to take that cut that the CNMG couldn't.
That's right.
That just goes to show you what insert geometry can do for horsepower.
Yeah, well, see, you have to consider too. Yeah. See, this is taking more horsepower than this machine will put out.
Yeah. Folks, that's amazing. I've never seen such a good example of, we were running that T insert. And it's funny because I don't think of a T insert as being a very sexy insert. It's not a new geometry. It's not what people are touting as the best, latest, and greatest. And it took a same cut that your CNMG said, nope, not happening.
That's right.
That's just based on the geometry.
That's right. That's right.
That's
So,
cool.
you know, and of course, that's based on the geometry on the material we're cutting. See, we didn't have that problem with the other
Right.
two materials
Right.
that we cut. Now we have that problem because this is 1045, which is different
A
grades,
little bit
tougher.
more. Yeah. What do you think the button cutter is going to do?
Well, I think it'll cut it, but you know what the problem is? It may string it because it's not going to want to break.
Doesn't want to chip break.
But these are usually pretty good at breaking, so we'll see.
That's a real. That's actually working
So
okay.
it's breaking it. So
Yeah, it is working okay. Holy cow. Oh, that's going great. You can see in the chip the groove lines of the chip breaker too.
Yeah. But typically these type of tools, see how it has a big long neck on it? You couldn't sustain that with the pushing on it real hard, so it's a positive insert, a negative insert. But typically these are meant to dive in like that.
Yeah, right. And obviously the radius means you're not bringing up a stress riser.
That's right. And you can dive in here and fool with it.
Beautiful.
Of course, it's breaking nice chips.
Holy cow.
Just like that.
I can't believe how hard you can run that. I can't believe it.
Yeah.
Now, I got a dumb question. How do you handle, folks, I can't emphasize, I mean, literally, it feels like a fireplace right now.
Yeah.
It's insane. How do you handle rotating that insert to, like, expose a new edge?
Well, this particular insert, all you do is loosen that screw up and just turn it.
No, I know, but do you turn it, do you try to clock it 90 degrees?
That's right.
Okay, so you get 4 edges.
Yeah, and if you're using it 180 degrees around there,
then you get
you
2.
have to turn it 180.
Yeah, right, okay.
You know, you could turn on one side with it. You know, there's smaller ones. I have a smaller one here. Okay, this is strictly one hand. That one's a neutral.
Yep. Okay, so this is a left-hand tool, and that's a neutral tool because it's in the center. If it were over here, it'd be a right hand.
And yeah, this way we can turn in both directions with that. This is a single direction.
Okay.
The ones I have, I'm sure you can buy them off either. These are Sandviks.
Yeah. Yeah, we bought a little Sandvik 2mm button cutter. We did it for a stainless job, and we had tried other inserts. And a good example, I just called Corey and I said, I can't figure this out. Tool wasn't cheap, but holy cow, just night and day.
That's right.
It just worked.
I mean, you can buy a lot of purpose-built stuff that works really well.
Yeah.
And that's getting with your factory wrapping and getting that. But I'm sure most guys, you know, they're looking at, woo, how hot that is. General purpose inserts.
Yeah.
To try to get it. And you see here, we're not having real problems cutting different steels here because most of the inserts that I have and that I use in my shop is mostly general purpose stuff.
Right, right.
I'm not using real high specialty stuff. And where you run into a problem is some of the steels that we've got over here, like stainless. It's a little bit more specialized.
Specific. I will make one recommendation, and again, Paul said this in the aluminum video, which is, I'm just going to say it, don't buy your inserts on eBay. Of course, if you want to try it, you can, but too much of a risk that you're going to get a counterfeit just is, especially if the pack of insert is new, but it's been opened. I would just stay away when you're learning.
Yeah, I mean, if you're working at a big company, they have departments that study this stuff, and they know what the inserts will do. They'll buy a specific brand and study it for a while, and then they'll buy another brand and study it for a while. If you're buying, and I don't want to run on the Chinese too much, but some of these guys are just, some of their stuff is just not made very well, and they're just not there yet. It's not their fault, really.
We have had luck with Sandvik. It's probably the more expensive, but it's really worked for us. But look, I mean, I've had some Sumitomos that were great, Mitsubishis that were great, Iscars that were great. I mean, there are a lot of really good tooling companies out there, and some of them are not quite as expensive when you're getting into them.
Yeah, that's the other thing. You can consider that. I mean, the prices of them are not the same. Sometimes there's not the technology behind some of them that there are others. Depends, and you know that costs money. Coming up with new tools all the time costs money.
Right.
So we'll go ahead and change out to. I guess we'll go to the 4140. Yeah.
Sweet.
Okay, now we've got the 4140 clamped up here. This is a little bit bigger piece than the other ones, but that doesn't make any difference. I probably should line that up a little bit better.
Yeah, let's dial it in. Paul, let's dial it in.
Okay, let's get it round first. Screwing it up, and you'll notice that it sounds harder, being 4140 it is. So you already get an idea that it's going to be tougher to cut it. In fact, you can even see here the chips are even a different color. It has to do with the alloy more than anything else. Okay, we'll go back here. We'll take 100 on the side with 5,000s like we did with the other ones.
Okay, so starting out at 5,000 per rev.
Yeah. Now you see it's just barely breaking it. Okay, that's 5.
So you said they're barely breaking, Paul?
Yeah, they're doing pretty good.
Okay, yeah, it doesn't seem, it's not a tight C, but it seems okay.
Yeah, that's perfectly acceptable.
Okay.
Okay, we'll do 10,000s.
Okay.
You can hear it, and you'll see they're tighter.
Definitely a tighter, and it's pretty, maybe a little smaller chip.
Yeah, they're going to be shorter because they're breaking quicker. Now we'll do 20. And that's pushing a little bit too tight.
Ooh, look at that.
Yeah, see, they're sticking together.
That's what it is. Well, first of all, burning the paper.
Yeah,
see how hot it is.
You can see here where there's more than a few chips in this one right here, and they're all stuck together.
Wow.
So it's starting to chain up.
Yeah, they're so hot that they're just actually welding together.
Yeah.
That's incredible. And you can see literally we're burning the paper. That's how hot that chip is. So that's not good.
No, that's hard on the insert. It's getting a lot of pressure on it. So we'll try 5,000, 200 deep. Where was that? Yeah, that's 200 on the side.
200 on the side, 5,000 per rev?
Yeah. You can see how they're flaking out.
So why is that not breaking now?
It's changing in chip breakers. See, if you remember when we talked about these designations, you know, whether it's a finish or a medium or rough, okay, that affects the chip breaker and how the chip breakers are formed on there. So if you go exceed the depth that the insert's designed for, then you get different.
So we need a roughing. This is a medium or finished insert in there because it's not breaking the chip.
It's probably a medium.
Got it. Interesting.
So
wow.
So it won't chip right.
Right.
With certain materials, and like you saw, we got away with this particular holder with 2 or 3 different types of material. They're different. Can't get away with it on this one.
What's tough about that is, you know, you may not know that, you may not realize it, because what Paul said, you had false confidence from running 1045, and then all of a sudden 140 it doesn't work, and it's not really your fault. It's not your fault as a machine operator. It's you just got to get a different chip breaker.
Yeah, you know, and if you have some practice and been around the shop for a while, and you go get a piece of steel that's meant to do something, and you put it up here and you say, well, this is 1045, and it starts cutting weird like this, then you go, oh, it's not 1045.
I've never heard of material mislabeled before.
Yeah, that's right. Well, and you know, you can do that in your shop, just like we were talking about earlier. If you've got a scrap bin, and like we're saying, you want to keep everything divided so you're not using expensive steel for a cheap project.
I tell you, it's tough to keep it organized. I have the best of intentions, and we can't do it well.
You have to be vigilant about it.
Because you face off your Sharpie, and then an hour later you forgot which part it was and which to rewrite it with, or the Sharpie wears off.
Yeah, that's right. It happens. I mean, it's harder in a shop where you got a lot of guys working in there. And some guys are conscientious and some are not.
Yeah.
So we'll take that.
The T again.
Yeah, we'll go back to the big heavy T.
This has been the surprise insert of the day. I can't believe.
Yeah, I can show you the box for this.
And you cut a lot of 4140. I know that. You know what you're doing.
Oh, we didn't cut heavy with the other one, but we'll go ahead with this. We'll go with 10 thousandths on this.
10 thou. Will you? It seems okay. Actually, it's great.
Yeah. And you see they're curled up a little bit too much.
Okay.
They're not breaking tight enough, so you're getting a little bit of string out of it. See how it's not really a C, or it's not really
because it's spiraling out like an ice cream cone sort of shape.
Yeah, that's right. So we can feed a little bit faster to get it to break better.
Okay. Feed fast. Okay.
Okay. We've got it on 10 thousandths feed. And you can see what kind of finish you can get there.
Yeah, great finish.
Yeah, see, that's pretty good finish because this has got a pretty large radius on it.
Okay.
So we'll jump it up to 20 thousandths feet. see, you could probably catch that in between. I went from 10 to 21, and this is what it's making now. You can see it's pulling it a lot tighter.
Yeah,
now, we just jumped from 10 to 21.
That higher feed rate.
Yeah, if we back the feed off a little bit, say 15, 16,
right,
then we're going to get a shape of it.
What you want.
That's right.
Yeah, so basically that may be the time where you go ahead and switch your gearbox.
Yeah, see, now I have it set up so this is 21, this is 10, and this is 5, and this is 2.
Right.
And
so you switch another lever.
Yeah, that's right. You got to switch some other levers around if you really want to get the most efficiency out of that particular cutting cycle.
Yep.
On that. So we'll go ahead and jump to another tool here. Okay, we can take the high feed insert. We'll try it. See if we got enough here to do that.
So this is that CNMG that's got the solid floor.
Yeah, and it's got a real high feed on it. Let's see if it'll pull it. Ooh, not going to pull it.
Nope, that insert.
Nope. Not going to pull that. So,
nope.
Won't do that. Then we'll go ahead and go to the radius insert. Remember, this is a positive insert. That's up on 20 thousandths. Let's take 200 to start with, see what it does. Take another 100 off of it. Whew. And it'll chip real nice when it gets harder like that because it's tipped on a break. Unlike some of the softer stuff we were working with, it doesn't want to break very easy because it's more ductile than this is. Now those are reasonably nice looking chips. Yeah. You can get the same type of chips. One thing we didn't demo I can do right now.
Cool how you can see.
Oh, that's my phone.
You can literally see the formation of the edge of the chip breaker of that button cutter, radius cutter in the chip. It's really cool.
Now, I talked a little bit earlier about having the same tool. I just wanted to demo a little bit. This might have to run up a little bit faster. You can get it to chip the same way, facing off. You should be able to get the chip just like that, going both directions. Now this will be effective because, just like John alluded to earlier, it's like the merry-go-round is going to get slower, so the chip's going to change as you go across the face. It's not going to get better. And this is a real problem if you don't have constant surface speed because it'll get real slow in the center and then the finish won't be that good.
Yep.
As you can see, it's chipping out in this fine. And like I said, you can get 2 of these holders, the right and the left. One for turning, one for facing. The only problem you have with facing this way is having enough room to get in there to face if you have the tail stock up here. And I use a tool like that for facing. And I have a tool over here I cheat with. I think John's seen this before.
What's your cheater?
This is a negative holder. You can see that the way the insert's mounted in here. But it has a positive insert.
I love that. Yeah, negative holder positive. So you get 8 sides, but
not only that, but you only get 4 sides because this is a positive insert.
Oh, it's a positive insert. Okay.
Yeah, but when you go down to face off down to 0, it has a huge angle on the side. Not only is it tilted, but it's got the angle ground on the side too.
Huh.
So it makes it easier to face down to nothing.
Interesting. That's a good trick. Cool.
Okay.
All right, folks. Well, Paul, thank you very much for the time and the help and the advice and being willing to share it. Fun fact, we're actually out of SD card memory, so we're going to come back and then film on another day and go ahead and bang through 303, 304, and some cast iron stuff. Sound good?
That'll do.
Awesome. Thanks, Paul.
Yep.
Again, folks, want to give a shout out to Alro. We really appreciate that they were able to provide us these drop pieces to help us film this video.